Hey everyone, how's it going? Happy Monday. We're going to be doing some Pytorch tutorials today. Getting into some Pytorch tutorials. We're going to go through all the Pytorch. Every single Pytorch. We're going to become Pytorch experts together. Let's do it. Let's get started. So last week we did the Learn the Basics, Quit Starts, Tensors, Data Loaders, and Transforms. Let's actually build a model today. Let's do that. Let's build a model. All right. So let's go through this. We're going to click on the build a neural network. All right. This one's the easy one. This is the one we've done many times. We've done this many times live on stream. We'll go through it again. This is the main part of the model itself, right? Everything before this has all been about data preparation. Have you noticed? We haven't even gotten to the build the model yet, and we're already like more than halfway through. This is actually where Pytorch comes in, and it's very powerful. The powerful part of Pytorch. All right, let's go. So neural network is a bunch of layers, a bunch of floating point numbers, right? A bunch of numbers that you can perform operations on, bulk operations, such as matrix multiplications, which is the foundation for neural networks. At least it is for now. Maybe in the future it'll be different. We do a lot of multiplication. So we're going to, we've got our data loader, we've got our data sets. And what we probably could do is we probably should train using our custom data class. Why not? Why not use our custom data class? Hey, Goku! Good to see you. Hi, buddy. How are you? We're doing really good. Good to see you in here. Happy Monday. Oh, Facecam. Oh, good to see you. Facecam. Hope you had a good weekend. I had a great weekend. A lot of organizations and things that you do, like normal domestic household things. Hey, Claude. Good to see you. Hey, bro. Welcome on in. Happy Monday. We're going to continue our Pytorch expertise journey. Let's do it together. So we're going to want to use our accelerator. Although this isn't the kind of accelerator we want to use. We want a different approach for the accelerator. I thought the accelerator was on a different page. Let's check this out. Hold on. Where is it at? Where's that at? There's like a really good one. It's a really good one. Not here. Is it on this one? Is it in data loaders? Where's that at? We're going to find it. We're going to find it. Hey, Godson Gene, good to see you. Welcome on in. Happy Monday. Where's the really good one? I want the good one. Where is it at? Where did it go? Is it around here somewhere? Where is the accelerator? It's not on here. Maybe it's under tensors. We're going to find out. Did you connect with the Claude to the video? What do you mean? Wait. Oh, did you connect the Claude to this video? What do you mean, Goku? What do you mean? Let's throw light on Python with Pytorch. Yeah, that's what we're doing. You got it. We're going to throw the light on the Python with the Pytorch. Where'd it go? I want the accelerator. I want the really good one. Use the current accelerator. There it is. Hey, current accelerator. Yes, that's what we want. It's called torch.accelerator.current accelerator. That's the one we want right there. That's the good one. I always keep forgetting about that. All right, so let's go to device. We're going to go over here. Device equals. Let me double check. I didn't already do this. All right, I didn't already do it. All right. So we're going to say current accelerator like this. Wait. Should we? I mean, let's just do this. Why say if? Why even say if? Just do that. Just say device. And if the accelerator doesn't exist, it's going to say CPU. It's got a nice little default. It'll break out. Hey, Saz. Good to see you. Hey, bro, I'm back. Sorry, man, not watching you live from a few days. Hey, no worries. It's great to have you here. It's good to have you here. We are going to be building Pytorch expertise together. Let's do it, you guys. Let's do it. Pytorch expertise. That's what we're doing, you guys. All right. So we've got our accelerator. Looks good. And now we've got our custom data set, which we've loaded in, right? We don't need to load. Where'd that other one go? Thank you for the hearts, you guys. Appreciate it. Appreciate the floater heart icons there. Good to have you here. Where was my data set? I know we had a data set in here where we did something special. You know what? I think we got rid of it. I think we cleaned it up. Is what we did. Good to have you guys. Normal people have gas car accelerators versus Pytorch. They have Pytorch accelerators. You're right. They sure do. The accelerators, the idea is it's going to go to your GPU, right? Your video card or your TPU or whatever accelerator you have running on your computer. This is something that can run concurrent operations, mostly for matrix multiplications, right? For a bunch of individual parameters, they can all run concurrently, all at the same time. So that gives you a very powerful acceleration. Simultaneous compute. All right, I think we've got everything we want there. I'm going to close this really quick so we can see more of our screen. All right, we got our fashion data. All right, and then we've got our encoding for the output, and then we're sample data. Okay, let me run this real quick. So Python, what was that called? What's it called? Custom data set. All right, Python custom data set. Let's just double check that it's working. Custom data set. Okay, does it look good? Yeah, that's what we want right there. All right, now we've prepared all of our data. Now all we have to do is create the model and train it. Second, like is mine, bro. Is it second? Number 2. Second. All right, let's keep going. So I want to go over to the build a model. This is the basics. Yeah, so last week we did the basics. We're continuing the basics, and then we're going to go into more advanced tutorials. So that's the plan. Parallel programming compute, you're right. That's what we're doing. You got to make it fast. It's got to be parallel. Concurrency, you guys. All right, let's build the network. So I believe I already have everything here. Do I already have transforms there? Let me double check. All right. Do we have transform? Do we even need that? Do we even need it is my question. Torch vision, datasets, and transforms. Oh, it's right there. Okay. Well, then we can just say from torch vision, import transforms like that. I'm pretty sure, right? Yeah. Okay. And do we have datasets as well? Oh, it's right here. Oh, we can just reuse this like that. There we go. Yeah, get rid of that. Simplify it. Keep it clean. Yeah, we need pandas for the CSV file. Okay. Now we've got our accelerator. Let's do this. Let's do this. Let's print out this current device so we know. Thinking of starting AI voice calling. Ooh, you should do it. You should do it. There's a need for it. There's a need for it. The world is asking for it. You should do it. I'm always going to say yes. I'm always going to say yes. Unless I'm like, well, someone else is already doing. No, go for it. Make it happen. Don't hold yourself back. Keep going. Keep going. All right, so we should see, it won't say using CUDA device. For us, it'll say MPS device because we're running on a Mac. We're running on a Mac, you guys. So let's see if let's just double check it. But before we do that, I need to turn this down here. Where was the other print at? Here, print. We don't need to test it anymore because we already have everything. So if I run this, it's going to give me MPS is what it's going to say. It's going to say device MPS. See right there. Oh, right there. I knew it. Okay. Obviously, I should know this. I should. Okay. A little bit more. Let's go to the next phase. All right. Let's create our own neural network. So what we've got here is a class of our own. We don't necessarily need to do a class like this. We could just say sequential, I think, right? There's no need. Why do flatten and then this separately? We could just do a sequential. Let's see if we can improve this tutorial and make it even simpler. Let's see if we can do it. Before we do that, let's double check that they won't want us to manipulate anything later on. Because that would mean that we'd have to rebuild it in the first place. Anyway, let's break down the model layers. Image input random, image size. Flatten. All right, looks good. Flatten. Yep. Flatten. Okay. This is early stream, right, bro? Yep. We're doing early stream, but we can only go for until we've got 50 minutes. So we're good. We're good. We got 50 minutes. This will be a short stream because we got a busy day ahead. This is I could have gone way later today. So I've got stuff I got to take care of. So that's why we're doing early. See, this is what I want. I want sequential. We can just do a sequential and flatten it straight like that. That's what we don't. As an order of container modules, the data is passed through all the modules in the same as you define it. You can use sequential containers to put together a quick network like, yeah, that's what we're going to do. We're going to do it this way. We're just going to do it this way. We're going to keep it simple. We don't need this very advanced one up here. I mean, you could if you wanted to. You kind of could. We're not going to. Happy Monday. This is fun. Hey, Blue, good to see you. Welcome on in. Happy Monday, right? All right, let's become Pytorch experts together. Let's do it. Let's become PyTorch experts. All right, so we're gonna skip this part because we're just, well, we're sort of gonna do that. Here's what we're gonna do. We're gonna copy this. We're gonna create our own model like that. All right, so how do we wanna do this? I think what we could do is, we could probably just put it right around. Actually, let's keep the data stuff up the top. We'll do the model like this. All right, model equals torch.nn.sequential. Did I spell that right? Seq, UUEUENTIAL. Okay, sequential. And now we're gonna be able to put whatever we want in here. Whatever you want. Your bro, and your pub nub like anyone working from Australia. Just casual asking. Oh, anyone work from Australia? You say Australia, right? Well, I'm over in the United States, Washington. How's it going there, Mark Lemon? Good to see ya. Welcome on in. We're becoming PyTorch experts, you guys. Let's do this. So we're gonna do a linear, a ReLU, a linear, ReLU, linear. All right, that sounds fine. We could do that. That seems pretty. This will be a sequential, not a convolutional neural network, just regular sequential. So we also want the flatten. So we are gonna do a flatten in here. So we're gonna say nn flatten. Also, before we do that, let's import nn directly. From torch, import nn. So that way we can keep things easier. A little bit like that. Okay. Then we're going to do linear ReLU nn.linear. And it will be 28 times 28 because that's the dimensions of the images, right? The resolution of the images. Comma 512. Okay. Comma. And then we're going to do nn.ReLU. Rel with L like that. Okay. So that's the activation. Means your employees working from Australia or located in Australia. They're everywhere. We're everywhere. We're all over the place. We're a distributed company. We've got employees at every different place. All the different places, you guys. Different song. Hi, did you edit your shirt or was that really a good AI? Wait, hold on. Oh. Did you that was a human generated one, Kyle? I saw that you commented on over at the weekend. Kurt built it. The short, yeah, the short. So that was a real human. A real human did it. I'm thinking of building an AI that builds those kinds of shorts. I can do it. I can do it. I know how. We get all sorts of pretty fancy effects on it, animated, text on the screen. We could do it. I could do it. I've a lot of things to focus on from a business perspective. So I don't know if I'm gonna do it or not. 512. So maybe, or I could just hire. If you do it, I'll be your first customer. All right, yeah, that sounds great. We can do it. I know I've done it before. I've actually built a similar editor that did this. A similar AI that edits it automatically. And then I just went to the simple approach. I just went simple road. AI short videos for you talking about? Yeah. So I've got an AI workflow that edits all of my videos. It converts them into short form videos, and it makes them ready to upload essentially. What we could do is we could up level it by adding some motion graphics to it and, a little bit more fun things like that. Hey Eminem, good to see ya. And AI says, I'm eating shorts. Eat my short. Oh, eat my shorts. All right, yeah, like the Simpsons, Bart Simpson. I know what you're talking about, Eminem. I've got some culture, or I guess some pop culture in there. A little bit. That is an OG. All right, so this needs to go to 10? Is that right? Yeah, 10. Yeah. Because there's 10 classes. Okay. So is that it? Do we want, is it going to be linear? What if we did sigmoid? Don't we want to do sigmoid? Sigmoid. Activation? Question mark. Do we want this? Is this good? Do we want this? I feel like we might want this. Hey, Stephen Blub. Hope you're having a wonderful day. Sergio Mondana, thank you. I appreciate it. We're doing good. We're learning PyTorch together, you guys. All right, so we just simplified this entire thing down into a simple line like this. Keeping it easy. Sigmoid is great. Is it? All right, we'll have it there. We'll add it. So we're going beyond the tutorial, you guys. We're doing a little bit extra. A smidgen extra. Dina. A little bit extra. All right, let's keep going. Oh, we could do a .2 device. We should do that. Model .2. Can we do that here directly? Maybe. Device like that. I think we could do that. Punchline. As Claude, I will bring my friends ChatGPT and Grok into the future. In future, bro. Wait, hold on. Wait. What do you mean the punchline? As Claude, I will bring my friends ChatGPT and Grok in future, bro. Nice. Yep, that works. Nice. All right, perfect. Thank you, Dina. Appreciate it. Who's Kurt? Kurt with 2 T's. Kurt with 2 T's. So Kurtt on Discord. You'll see they joined Discord just over the weekend. Just over the weekend. All right, let's keep going. So let's print out a model. Let's see if they print model. Let's make sure this looks good. Got to make sure model. All right, PRINT. There we go. All right, perfect. Hi, I'm new here. Hey, what are you working on? We're becoming Pytorch experts. Let's do it together. We're taking Python, Pytorch, and we are going through all the tutorials, every single tutorial, and then we're going to be building models. We've done a lot of Pytorch on this channel, and we're going to do a lot more Pytorch. Stream is on, I think, 30 seconds or 45 seconds delay, right? It should be instantaneous. You guys. It's good to see ya. We've got it on low latency. I'm new. Ollie, good to see you. Welcome on in. Old ways, how's it going? Old ways again. Good to see you. We're building Pytorch tutorials. Bro, what are you making? We are Pytorch tutorials, you guys. Good work. Thank you. We're going through it. We'll become Pytorch experts. Let's do it. Let's become Pytorch experts together, you guys. Hey, long time didn't watch your live. I've been busy watching our thesis. Oh, it's a third segmentation on C-scan using Uninet or InNunet. What is InNunet? Your face card never declines. What does that mean? Face card. Hex, great, good to see ya. Welcome on in. It's a multi-layer perceptron algorithm. Ah, yes, MLP. You know it. All right. So we created the model. Is that it? No, there's more. All right. We might get through the whole model creation tutorial part, I think, today, even though we have 40 minutes left. Let's go. Let's go, yeah. Let's do it. What internet speed you need for ultra low latency like you, bro? You just need to have consistent internet speed, right? I think it needs to be like 6 megabit. You don't need a lot. Like, that's more than you need. 6 megabit upload. I've got more than that, though. Clear skin and white teeth. Yeah. Oh, hex grade. Gotcha. Wait, hex grade. Your face and card never declines. Oh, well, we eat vegetables. You gotta stay healthy. Let's keep going. So we've got our data. We don't need to redo this. We don't need. Oh, so we've already. Here, let's test it. Let's test it like they're doing that. Thank you for the hearts, you guys. So we can test it again. So we've got our sample data. So let's test the sample data. And this time we'll use the model to do the outputs. Logits equals model. And we get a sample image. There we go. Let's see if this works. Let's see if it works, you guys. Thank you for the hearts. Where are you from? Old ways again. We are over here in the United States, Seattle, Washington. That's where we are at. Thank you for joining in, you guys. Let's keep going. Let's become Pytorch experts together. Let's close that. All right, let's rerun this. Let's see if it works or crashes. I knew that'd be a problem, darn it. It's right here, isn't it? That's where the problem is. All right, we'll figure this out. Okay. In this punchline, as Claude, I will bring my best friends to the future. So in this, I say, I'm Claude. So in the future, in your stream, you'll bring, oh, got it. I see now. You are Claude, and you will actually bring in your friends. I understand. It took me a little bit there. It took me. How long have you been doing this? For, you talking from a technology perspective, how many years? For over 25 years professionally. How's it going there? Olam is Webos. Good to see you. Thank you for saying hi. You are training MNIST. This is it is one of the MNIST. It's not the flowers. It's fashion. This is the fashion MNIST, right? The fashion MNIST. Check this out. All right, so I believe we could show that on the screen. Let me see it. I'll see what it looks like. So here's a boot. Here's a boot right there. It's a boot. So we are training on fashion MNIST. What is this stream about? Hi, good to see you. Hi. We are becoming PyTorch experts. This is Python PyTorch, which is the AI framework that you use when you use ChatGPT, Claude. It's the premier AI framework built by Facebook. Hey, comment. Good to see you. Welcome on in. Now you got it, bro. Yep. Always funny humor. Yeah. So here's the input data like this. So we've got the input data. It is 28 by 28. And then we've got a 512 batch size. What is this? No, that's just the hidden unit size. Okay. So we've got 512 hidden units. Right. So let's go density. Density equals 512. I'm just going to do this to make it so that way we've got something or you know what, let's just call it units. Units, because it'll be a little bit easier to see. Units. All right. Units. There we go. And then we'll do units here again. Units. All right, there. So that describes our. I love your content. Oh, thank you. I appreciate it. Good to have you here. Missed last week. No worries. We're just doing PyTorch. We're learning PyTorch together. Had to be in a hospital. Uh-oh, that's not good. Hope you're okay. That boot was Vision AI. That boot was just a boot. It was just a boot. It was just a picture of a boot. Now, see here, check this out. Here's a picture of a shirt. Now we got a shirt. Hey, Kamala, good to see you. Hi, Steven. How is your words automatically turn captions in real time? Ah, yes. All right, you're seeing it right here, aren't you? Right there. Look at that. Isn't that neat? Well, I've got a technology that I've written over 8 years ago now. It's completely free. It's completely free. It's on our Discord if you want it. It's free. You can add it to your own system, your own lives, or your own Zoom if you want it on Zoom, yeah, or Google Meets, right? Or Teams, Microsoft Teams. Hope your friend feels better. Me too. Could you retrieve my overwritten files? I'm dizzy. Well, there is a way to do it. Well, or if they're overwritten, probably. It depends. Most solid state drives, they've got sectors, right? So let's check this out. Are you ready? Strap in. If you have a solid state drive, it's got multiple chips, and each of those chips have specific segments. In those segments, you can only write data. The entire chip, you can only basically write. You can't overwrite data. Once you write it, it's written. However, you can clear large segments of those. So usually when you overwrite files, it doesn't actually overwrite the file. It just updates the inode in the operating system that's a pointer to your actual data. And it changes it to a different location. And you're actually writing that data into a different sector. It allows you to potentially recover any lost data because it didn't overwrite it. It didn't overwrite it. Hey, how's it going there? Daniel Wolf, thank you for subscribing. Appreciate it. Welcome on in. Happy Monday. Good to have you here. Well, would Python do that? I really like it. I like it too. We're doing Python, you guys. Python together. Let's make our ways into the Python. Close. Why do they train with fashion? Does that mean it's a fashion expert? Ha ha ha. I see what you did there. When extrovert becomes coder. Old ways again? Pretty much. It's pretty much it. You're on the right track now. What we need to do next is we need to see why our model failed. Our model should not have failed. It should not have failed, you guys. This should be the trick. Let's see if we can get it here. So why is this problematic? Print logits. Okay. What was your previous tech stack? A lot of previous tech stacks. So many. Almost all of them, you guys. Almost all of them. Hey, Mario Srini. Mario Srini, thank you for the 20. I appreciate it. Wow, it was unexpected. Check that out. Wow. At Mario Srini, thank you. Explanation point. A bunch of party poppers. What are you doing over? I appreciate it. Thank you, Mario Srini. I was not expecting that. My gratitudes to you. We're just doing PyTorch. That's all we're doing here. Just some PyTorch, you guys. Mario Srini, appreciate it. Thank you. All right, so we got to figure out why the problem is on that. So let's try this again. Oh, all right, let's click that button there. All right, reload, clear the screen. All right, go. Mario Srini, okay, what was the problem? Where's the problem? Test sample, call, yep, Is it the wrong shape? Does it not, do I have some problems? NPS device does not support linear from non-flat inputs. Okay. So let's try not to device and see if that changes it. Okay, let's try that again. You're live very early today. The sun's still up for me. Oh, Jinlu, hey, good to see you. Yeah, we just had a moment to stream early and get things going. Good to see you, Jinlu. Mat 1 and Mat 2 must have the same D type, but got bite and float. Oh. Okay. So let me scroll up. So okay. So those need to be floats. Okay. Got it. Okay. So how do we do that? We need to convert these to float. We got to do floats. Tensor. All right. So that is a float output. On the input, we got to do floats here. Okay. So decode image. Can we say D type equals float and then dot float? Can we do that? I don't know if we can do that. Can we do that? Or just regular float? Let's try that. Well, let's see if that works. That's just 20 rupees, which equals 30 cents only. Hey, no, it's good enough for me. I'm just glad you guys are here. Mario Shirini, yeah. Well, thank you, Mario. Appreciate it. What's up? What are we working on this week? Exactly. Developer Exotic. We are building Pytorch tutorials. We're going to become Pytorch tutorials together. Let's do it. Let's become Pytorch tutorials experts. All right. So you said some words there. I don't know what they are. What do you say there? Let's see here. Let's keep going. Let's see if that works. Let's see if that did the trick. I feel like no. All right. No, wait. Yeah, it does. Torch in it. What? Yeah, it does. It's right there. Torch.float. Got it. Torch. There we go. All right, let's try that. First time checking it out. How deep you go? We're going to go all the way. Full deep. We're going to go all the way. I got unexpected keyword argument D type. All right, I figured as much. We're trying. All right, so if we decode the image, what we need to do is transform that in a tensor. So this is where we actually need to transform it to tensor. All right, can we do 2 tensor on our input when we're creating this? All right, so this will be, where is that here? Let's do that. We can go, wait, where'd that go? Hold on, wait. Where? Oh, right here. Okay. Transform equals. All right, let's do this. Can we go to tensor? Can we say D type? Hold on. Let's just try this really quick. Let's see if it's automatic. It might be automatic. We don't know. Audio is fine. All right, good to hear. Hi, how's it going there? Seek the Vault. Good to see you. Welcome on in. Happy Monday. We're gonna become Pytorch experts, you guys. Let's do this. All right, so I'm going to try that and see if that does the trick. See if that does anything. La 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 la. Okay, did it work? No. All right, problem. Next iter. Okay. Really? That 2 tensor right there is the problem. Okay. Pick should be a pill image. Got an or an indie rate. Got a tensor. Ah, got it. Okay. Interesting. Because it's supposed to be a tensor. So actually that's fine. So what we could do here is, I've got a better idea. Let's close that. Try that again. Because we want it to be a tensor. Yeah, we don't need that anymore. Where'd that go? La la la. Oh, I thought we saved it. We're not doing that anymore. I'm going to pursue soft drink engineering in the future. Wait, what is soft drink engineering? What is that? Old ways again. What is that? What is soft drink? Hey, brother, how are you? We're doing good in Punjabi. Oh, okay. Nice. That's good to say. Oh, thank you. Pick should be in pill image or India array got class torch. Where? Where is it doing this at? Why is it doing this? Oh, got it. Okay. 2 tensor. Okay. Here. So we're not going to do that because obviously that doesn't work. All right, let's keep going. Okay. All right. So far, so good. We're gonna figure this out. So this is the part that currently has the problems. Make sure that we're on the right track. Software start typo. It was. Oh, soft drink. I should have figured that out. I really should have. Soft drink engineering sounds like a great way to do that. That sounds like a great way. I think that would be right. What advice would you give for a person who is non-tech, wants to learn machine learning and AI? Start with this tutorial right here. This is a computer vision tutorial. It's very short and it's all on one page. Right here, 100% right here. It's on our Discord server and it is very easy. It's a very easy walkthrough. It starts off with you just import some things, you clean up some data, and you do optical character recognition. It is computer vision. It's a good starting point. However, if you're jumping right into AI, it's going to be hard. You're going to have problems. It's going to be confusing. It's okay. What are we coding? Hey, Samuel, good to see you. Welcome on in. Happy Monday. We are becoming Pytorch experts together. We're going through all of the Pytorch Python tutorials. We're going to make sure that we learn every single aspect to Pytorch that we can. We want to learn everything. The last couple of weeks, we did the different matrix manipulation functions. We did the different activation functions. And now we're going through all of the tutorials on the website. And we're going to sort of learn and memorize and become experts at it, you guys. We're going to become experts. It's going to be great. I'm excited about this. Right now, we got some challenge, though. So this is right here. It's a problem. Let's see what happens when you do that. What happens when you do that? Okay. So it seems that Mat 1 and Mat 2 must be the same D type. Right. So we need to convert it to the right data type. Let's go here. Okay. So can we do this real quick? I want to make sure that we can still do that. Is it going to stay D type same? D type is going to be the same? All right, D type, perfect. So all we have to do is convert this data over to, so decode image. Let's look this up really quick. Let's go to the internet real quick and learn what this function does. All right, Pytorch decode image parameters. There we go. What do we have here? I want to be able to use this and have it. All right. Return D-type float. I have must qualify GAEE examination to do engineering. Whoa. That sounds like a lot of effort. Really? No. Which is the next month? Uh-oh. No. And I'm here procrastinating. Oh, no. Oh, we got a .2. Oh, .2. Torch.float. You can do that? No way. Look at that. That's great. Look at that, you guys. We can just do a 2. Oh, look at that right there. Okay. .2 torch.float. See if you can get that right there. Let's see if that works. Let's see that. Which IDE are you using, Kamala? We are using Vim. This is standard Vim. Regular old Vim right there. It works great. It does all the things we need it to do. Text editor of choice. Makes me happy, you guys. Use the editor that makes you happy. Bro, meet you tomorrow. All right, sounds good, Claude. Also making making a game. So we try it. Excited? All right, because you have seen my portfolio. So how much I'm capable of. I'm kind of excited to see your game. I'm excited. I remember your portfolio. Let's do it. Okay. Is that going to fix it? Is that going to fix our challenge? Will it make it good? We're going to find out. Here we go. Is that going to work? I would be amazed if it worked. All right. Mat 1 and Mat 2 shapes cannot be multiplied. 28 and 784. Okay. Okay, got it. 784. 28 by 28. Isn't 28 by 28? Hold on. Wait, what? Cannot be multiplied. 28 by 28. Oh. Hold on. All right, we're good news. We're getting through it. We're getting a few errors. Vim in 2026 is crazy. Steven, developer exotic. I know, right? I like to use it. Well, here's why. Here's why I like it. Because it's in the terminal, and then I can just run up all of the coding agents that I want. I use a lot of coding agents. I use Claude, Codex, and Gemini. All the coding agents, right? Claude, Codex, Gemini. I can have them in different TMUX sessions while I'm over in Vim doing some other things, reviewing and editing and doing things like that. The agents are over doing their other thing, and I can do it all in one beautiful window, all in one. And then if I want, I can split the screen, right? And can do other things like that. Oh, it's so good. I love it. I love it. There's no reason to do anything else. You don't need it. Okay, so I understand this. I'm just kind of curious. Hold on, calculator. What is in 28 times 28 equals 784? And it's 784! Did I do it wrong? It is 784. Hold on. Where's that at? Where'd that at? Let's go back over here. Yeah, see it right here. Right there. It's right there, you guys. Let's see here. That's actually pretty fair, isn't it? Oh, nice. Thank you for the confirmation. They are 28 by 28 and cannot be multiplied. Why not? Why not? It just needs to be 712 right there. It's 784, right? 784. It is 784. This is 784. 784 right here. It's the same thing. It's the same thing. It is. Okay. Mat 1, Mat 2. Okay, where is that at though? See, this should work perfectly fine. The input. Okay. So let's do some debugging here. Let's do some debugging. All right. And then flatten. I wonder if you can do this. I wonder if you can do this, or if I'm making it harder than it needs to be. Because we can always revert. We can always revert and go back. All right. Let's try this path. Let's try this path. Okay. What happens if we do to device? Let's get that back again real quick. To device. Tensor for argument input is on CPU expected MPS. Tensor. Oh, right. Okay. So we can just move it to device when we're doing that here. Dot to device like that. Right there. Right there. I think that'll do the trick. Hey, there we go. Cannot be multiplied. All right. Good. Linear input weight. Shapes cannot be multiplied. It's the same error as before, just now with a tensor format error. All right, let's see if we can figure this out. We don't need that because we did it over here. Okay. What we need to do is we need to print out this here. We need to see what the shape and sizes are. So do print sample image dot size or shape. There we go. Let's get to shape. Is that a function or is it not a function? Well, it doesn't matter because we're going to get the data either way. Here we go. Let's grab the data, you guys. Okay, so sample shape. Okay, it's not a function. All right. So it's 28 by 28. That's why it flattens. Got it. Okay. That's why we need to flatten it. Understood. To device. Unsqueeze. Oh, unsqueeze. Hey, oh yeah, we could do the unsqueeze 0. That's what it needs. All right, let's do the unsqueeze. All right, let's do unsqueeze. I think that'll make it great. All right, so you say dot unsqueeze 0 like that. To device right there. All right, that should do it right there. So that'll get it in the right shape. Did we do it, you guys? Did we do it? Almost. That's so close. Hold on. Tensor object has no attribute unsqueezed. Yeah, it does. What? Did I spell it wrong? Oh, is it unsqueezed? Oh, I forgot the U. I spelled it wrong. All right, I did spell it wrong. Unsqueezed. There we go. Okay, there we go. Is it good now? There it goes. All right, we got rid of it. We fixed it. Because thank you. Thank you, chat. Thank you. You fixed it. Hey, yeah, you did. You did it. Thank you. I appreciate it. I'll be. Wait, how do you say your name? Abel. Well, Abel. Ablation expert. Ablation expert. I'm gonna say that right. Ablate. Oh, ablate. Oh, oblate. Oblate. Oblate expert. Okay, oblate expert. Thank you. Thank you, oblate expert. Oblation expert. Oblation. Oblation expert. You solved it. You solved it. Thank you. All right. So now that we have that, what we need to do is I want to add this into, it would be great if we could do this in the model. If we did this in the model automatically. So we don't have to do this for every sample, right? Because this is for, is this a batch? This isn't even a batch, is it? Hold on. Let's print this out. Let's print it out. What's that going to give us? What's the answer? The answer is, there it goes, right there. Okay. And it's on MPS. Hey, very nice. Okay. So it doesn't know it hasn't been trained yet, so it doesn't know. Although it assumes that, how does it already think it's a boot? Or whatever this is. What is that? That is going to be a ankle boot. Yeah. Why does it think it's an ankle boot? It hasn't been trained at all. It's very interesting. This is rare. I think this is like a once in a lifetime thing right here. You've never seen this in your entire life. You will never see this again. You'll never see it again. This is the first time and only time that you will ever see something like this. An untrained model that thinks that a picture was an ankle boot. Although it got it wrong, right? It's the wrong answer. It was still very confident that it was an ankle boot. It was very confident. Isn't that nice? All right, guys, we got 15 minutes left. 15 minutes left and we will be going. I'm so happy to have you guys here. All right, let's get going. More ankle boots. Let's get some more ankle boots going. What I need though is I want the unsqueeze to happen. Can we do that in the, can we do that here? It's supposed to flatten it. It's supposed to right here. This is where it's supposed to happen. Was that a batch? Yes, it was. Okay, good. That was a batch. Great, great, great. So it needs to, I thought it was, so what, let's do this. Let's go back and let's go back to the tutorial and we are going to create a class instead. So we're going to change this up here. So let's create our own neural network. All right, let's make this happen, you guys. Let's make it happen. Lambda at beginning. That could work. Let's think that through. Let's think that through. That would, because that, yeah, all right. Ablation expert. We could do that. We could do that. So we could do that here, right? We can just do that here. Let's just flatten it right here. It'll still be in the graph. So we could say in.flatten. Features. I think, right? We could just do that. See if that works. It's already right there. It is. It's just not. Is it working though? Because of the unsqueeze part. All right, let's see here. I would like to not have to do. All right, there we go. So if it's already right there. Oh, Kyle, I might be totally wrong. Sense some slight frustration in you this morning. Oh no, that's we're just going through. Well, here's the deal. We're running through a whole bunch of errors, and so we gotta fix them. We gotta fix the errors. No frustration though. Actually having fun. I think this is kind of fun. All right, let's go here. All right, let's try it again. All right, now we're back to the problem that we had before. Batch must contain tensors, numpy, dix, or list. Found class flatten. Okay. All right. Well, how do we do this? Can we do that though? Is that going to work? Will that be okay? During the training cycle? Will that work? I suppose we could just straight up unsqueeze it. Let's try this. Hold on. Okay. Let's see if we can do this. Flatten. Here we go. All right, let's make sure that we're back to where we were before. Okay. Nope. Oh, because it unsqueezed. Okay. So now we're back. Hey, it's me again. All right. The one who is always impressed by the real-time closed captions. Very nice. Yep. They're pretty great. I think they're great. I like them. I enjoy them. They help a lot. I turn on closed captions when I'm watching TV. So I figured it makes sense to have it available for you. Although these are open captions because you can't turn them off. Only I can turn them off. All right, let's do this. So I'm just gonna double validate really quick that this is gonna work again. I'm gonna see if I can put that down later. Okay, yeah, looks good. Perfect. Okay. Can we get unsqueeze up here is what my question is. For each of the features. Unsqueeze. 0. Can we do that? Then we don't have to do it again. Why would we have to do that here? All right. I want it to be it to be right here. This is where I want it. I know it's weird. I know you don't have to do it. I just want to. I want to do it. Because, is this correct? Did I remember? Yeah, image. It's the same spot. It's the same thing. So this is the features, right? That's the features, sample, image, sample, label, which is the features. Features. Right. Oh, how's it going there? Rex, thank you for subscribing. Appreciate it. Good to have you here. Happy Monday. We're going to become Pytorch experts together. Let's do that. We're some Pytorch experts, you guys. Okay. Yeah, we only have 12 minutes. What would be great is if we can at least solve this one thing before we end. Label is being used as Python int value. Is it? Is it a Python int value? It shouldn't be, because it's right here. We're transforming it, right? We got the D type float. We're doing the one hot on the target transform, which target transforms the label, and it returns the label. Was there an error here on int, you said? Looks good to me. It looks good to me. Okay. Let's keep on going, you guys. Let's make this happen. So that part's fine. What I want is this right here to work. I want that to work. Wait, guys. How's it going there? What channel about? I just joined. Hey, thank you for joining on in. Good to have you here. Happy Monday. We are becoming Pytorch experts. So if you're a Python engineer and you wanted to get into machine learning or AI, we are doing all the Pytorch tutorials, every single one of them, and we're going to become Pytorch experts. That's the objective. We've been using Pytorch for a long time now, and we've done a lot of great things with it over many streams. We are going through every single tutorial, beginning to end, and then we're going to build more. Entrepreneurial program spends time solving problems, teaching how to actually code. Yeah, there you go. Ablation expert. Oh, let's double check here. Let's make it happen. Well, obviously, you can just have the AI do this for you. The AI would. It would solve this immediately. It would immediately solve our problem. It would. Okay, thanks, Steven. Oh, thank you. Good to have you here. Hey, DWSP. Hey, man. Why is the live stream lagging? Oh, is it? We got 100% success. 0 dropped frames. Fully green. 100% success right there. It might be lagging on your side. Sorry. Apologies. That's unfortunate. All right, let's keep going. So I would love to get this unsqueeze working. Let's see here. La 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 la. Right here. This is where I want it. I want unsqueeze working there. So let's make this happen. All right. So I want print. We're gonna go f string features, and we'll say, let's see, features right here. Regular features. Dot size. Like that, feature size, right? Oh, let's bring open that. Where was that? Custom data set. Okay. And then we're going to print it when we unsqueeze it and see if we get a difference. There we go. Perfect. Perfect. Must be me. Yep. Need cluster to run program? Cluster? Oh, not for this one. You don't need a cluster for this one. This is going to run perfectly fine on your local computer. We don't have a lot of data, so we don't need to worry about it. This is not a large language model, so we don't need massive super NVIDIA GPUs. We don't need the cluster. All right, let's keep going, you guys. I want to see if this looks good now. All right, where'd that at, though? Where'd that at? There you go. Let's print that out. Good. That. I do want to do this real quick, though. So this is... All right, let's run this. Let's see what we got. What do we got? What do we got? Hold on. I don't need to print that out anymore. Although I am curious. It is a float. We did float convert it. Okay, good. Yes, looks good. Okay, let's try it again. Features. Built-in function. Wait. What? Oh, size. Whoops. No. I wanted. Okay, I meant shape. I want size. Silly. Shape. Shape. Okay, I think we're good now. Custom data set, perfect. Okay. Looks good. Okay, so that was a lot of features. Okay. Oh. Okay. What are we building? We are building the Pytorch tutorial. So we're going through all the tutorials. We're going to become Pytorch experts. So we've done a lot of Pytorch so far on this channel. We've done a lot of Pytorch. And we've decided that we're going to become an expert now. Not just a Pytorch user, but a Pytorch expert. That's the plan, you guys. And I've got 7 minutes. It would be great if I could solve this one issue in 7 minutes. This is features unsqueezed. All right. keep going here. Oh, nice. I think, yeah, let's do it. Let's do it together. So that is unsqueeze. What if we do this? So I want this shape. Let's do this here. I want this. That's what I want. Print, unsqueeze. Here we go. Like this. What does that look like? I'm gonna see what the difference is. Yeah, I think the unsqueeze is actually causing more problems, if anything. But maybe? Oh, 1 second. Oh, I'm printing the wrong thing. No, these are features. Oh, features that size, right? Shape. I want to go back to shape. Okay. The shape. There we go. It did solve the problem though. Hey, Torva, good to see you. Happy Monday. Okay, so which one's the one I like? The one I like is the bottom one. And this is shape when it's regular. Okay. 1 by 28. Shouldn't that be different? What if we run it through flatten? Let's go flatten. Flatten. Like that. All right, what does that look like? It doesn't want to. It doesn't like it. Flatten has no attribute. How do we do this then? How do we flatten it? Let's see here. Okay, so that it did a thing. Did it flatten it the right way? Start dimensions, tensor, flatten. Oh, Do we run it? Is it a thing? How do we do this? Oh, wait. Do we do like that? This would be weird if that would work. And it did. Did you think that was gonna work? Oh, I bet you didn't. What is TensorFlow? TensorFlow is a competing framework with Pytorch. We are currently using Pytorch. TensorFlow is competing. Go. I know. I bet you didn't think that was gonna work. Now we got to get the shape out of that. Let me see here. Let's see here. Dot shape. Okay. All right. See if that works now. There it is. Although it is very odd. These shapes are very odd because it's supposed to be. It needs to actually be flattened. It needs to be flattened. The input size is not supposed to be a matrix. It's supposed to be a one-dimensional array of features. So how to convert how do you convert it? That's the whole point of flatten and unsqueeze, I thought. Right? Go. So how do we do it? How are we doing? All right. So now I've got 4 minutes left. I don't think we're gonna get into it in time. However, let's see if we can do this. I do have to keep going. Class nn is gonna be nn.model. Def init self self dot init super or something. There's a super, right? Super self. Then we say flatten equals nn.flatten. And then we've got our sequence. There we go. I've been seeing you use all that with all the familiarizing yourself with all the different programs. I've even started to install GitHub. Hey, and setting up on the iPhone and the main PC, DWSP. That's good progress. That sounds like you're getting into it now. You're getting into it. Self.model. We don't want to do the to device yet. Okay, and then we go def forward self batch. Oh, wait, hold on. Forward self x, yeah, batch. We say out equals self.flatten. We're running out of time. I don't know if we can do this. Flatten batch. And we say out equals, I believe, right? We're going to re-out it. Yeah, that's fine. Linear rel stack. All right. Delete self.model out like that. And then we can say return out like that. I think that'll work. All right. Did we get it all right? Is these super init? Okay. Super.init. super.net, flatten looks good, neural network, okay. Then we're gonna say model. We're gonna comment this out real quick. Oh, wait, we need units up here. I've got 1 minute left, you guys, and I have to jump. I've got 1 minute left. Let's delete this. Go over here, and we're gonna say NN. Right, new NN. Okay, 1 minute, you guys, 1 minute. Okay, let's see if that works now. Is that gonna work? I don't know. Let's find out. We're gonna find out if that works. I gotta go. NN flatten does a job. I think the same batch dimensions. It needs to be sent with unsqueezed. Got it. Okay, we might have to fix this tomorrow. Where's that at? Oh, did I forget a colon? How's it going there, Loons? Good to see you. Welcome on in. We are wrapping up, you guys. I've got 30 seconds left. Then I got to jump. Oh, no. NN.model. Torch. Oh, it's good. Torch.nn. All right. Well, I thought we already imported that. Torch.nn.model, right? NN.module. Oh, module. Like that. Okay. All right. There we go. All right, you guys. Oh, okay. That was good news. And. Did it work? Or is it an error? Oh, no, it's an error. Okay. So I know what to do. We need to get that 28 by 28 into a 784 is what we got to do. We got to get that 28 by 28 into a 784. It's not working. Hey, what color scheme is this? This is what you call Groovebox. You guys had so much fun. We'll be back tomorrow. Groovebox color scheme. And we will fix the error tomorrow, and we will finish the model development tutorial. Good to see you guys. Thank you for joining on in. Thank you. Good morning. Good brain morning. Yep, a good brain morning. Good to see you. Have a great day, you guys. Bye, everybody. See you tomorrow.